The journey to Mars began with the launch of the first successful mission to Mars, the Mariner 4 spacecraft, by NASA in 1964. Since then, numerous other spacecraft and rovers have been sent to Mars to gather data and explore the planet's surface, atmosphere, and geology. The next phase of humanity's journey to Mars involves manned missions to the planet. Several space agencies, including NASA, ESA, and Roscosmos, have launched robotic missions to Mars to pave the way for manned missions.
In addition to habitat development, establishing human life on Mars also the key to addressing the challenge of providing food and water for humans on the planet. Scientists are exploring various methods for producing food on Mars, including hydroponics, to wait and plastic to regulate human activity to prevent contamination of the Martian environment. Despite the significant challenges, establishing human life on Mars holds great potential for advancing scientific research and opening up new avenues for.
This week, NASA scientists shared observations suggesting that a mighty river built much of the sedimentary fan originally thought to contain delta deposits in Jezero crater. So, how does this affect the search for life on Mars? On this episode of Mars Guide, Perseverance was sent to explore and sample an ancient delta deposit in Jezero crater, an ideal place for preserving microbes if they ever existed on Mars. That's because deltas commonly have thick accumulations of clay minerals, also known as mud, which capture and preserve organic matter. But Perseverance has not found clay-rich mudstones. The most promising candidates were in the informally named bacon strip, but they turned out to be sulfate-cemented siltstones. Perseverance has spent the past 3 months in a phase of the mission originally named the Delta Top Campaign more than a year ago. It was renamed the Upper Fang Campaign, short for alluvial fan, as it got underway. This was a response to what Perseverance was finding and not finding. Deltas form when rivers deposit sediments into water. Alluvial fans are built on land. The difference matters in mudstones because alluvial fans are not real. Now another type of terrain is coming into focus. Curvilinear features recognized from orbit more than a decade ago were interpreted as meander bends of a river. Meandering rivers migrate over time, depositing sediments known as point-bar deposits on the inside of meander bends. But meandering rivers form on nearly flat land, not sloping alluvial fans, so something seems amiss. In late February, Perseverance rolled past a small hill that's part of some of the most prominent curvilinear features on the upper fan. Here's how it looked to Perseverance, and here's Mars Guide for scale. The 110mm zoom on Mastcam Z was used to build up a high-resolution mosaic from 18 individual frames. What it captured appears to support the meandering river hypothesis. Look at the stack of sloping layers. They resemble the sloping point bar deposits of a meandering bend, and their height represents the minimum depth of the river channel, if that's what formed them. This scene also shows an unearthly feature, a small impact crater that formed much more recently, maybe hundreds to thousands of years ago. It's visible from orbit, which is how I recognized it and how I was able to figure out its size. Perseverance left this hill and drove back through at 2 nearby sets of curvilinear features, parking at the end of rows of fractured bedrock. Mastcam-Z shot an epic mosaic of this landscape using 203 individual frames. This same scene includes the hill with a stack of sloping layers. The relationship between the two favors the interpretation that in this location, we're looking down on point bar deposits that have been planed off by erosion, exposing the stack of sloping layers from the top. Perseverance has since moved on and sampled one of these rocks in yet another location of curvilinear features, as I presented in episode 104. It looks like a coarse sandstone with angular grains, which, although not a clay-rich mudstone, was shown to be rich in carbonate, another mineral good for preserving biosignatures. So at this point, we've got observations supporting a hypothesis that, borrowing now from the book and movie, a river ran through it. If a meandering river did indeed produce the curvilinear features of this landscape, this is a place not quite as good as a river delta in the search for ancient Martian microbes, but it is better than the debris flows and flash flood deposits in the revealed fan. Still, they would.
By 2040, Mars will no longer be merely a distant, mysterious planet explored by robotic rovers. Instead, it will become humanity's new frontier, hosting the first sustainable human colonies. Life on Mars will represent a remarkable blend of advanced technology, unprecedented human ingenuity, and a pioneering spirit that reshapes our understanding of existence beyond Earth. Arriving on Mars, the initial settlers will face immediate challenges. The planet's thin atmosphere, composed primarily of carbon dioxide, makes outdoor activities impossible without specialized protective suits and helmets equipped with oxygen supplies. Yet, human adaptability, coupled with rapid advancements in technology, will have made the first Martian bases both functional and comfortable. Habitats, partially underground or shielded with specialized materials, will provide protection from the harsh radiation and extreme temperatures that characterize Mars. One of the most significant achievements of Martian colonization by 2040 will be the establishment of a sustainable, self-sufficient ecosystem. Greenhouses powered by solar energy and supported by advanced hydroponic systems will produce fresh food, crucial for survival in this isolated environment. Plants such as potatoes, leafy greens, and legumes will dominate agricultural efforts, chosen for their nutritional value, rapid growth, and adaptability to controlled environments. Moreover, synthetic biology will contribute significantly, allowing scientists to engineer plants that thrive under Martian conditions, consuming carbon dioxide and releasing oxygen to enhance habitability. Energy will primarily be harnessed from solar panels strategically placed to maximize sunlight exposure. Due to Mars' frequent dust storms that obscure sunlight, backup energy solutions, such as compact nuclear reactors or advanced battery storage systems, will be vital. Innovations in energy storage and transmission will ensure a consistent and reliable power supply for all operations, including life support, agriculture, and research activities. Daily life on Mars in 2040 will revolve around routines shaped by scientific research, habitat maintenance, and personal well-being. Colonists will start their days by monitoring environmental controls, ensuring oxygen and water purification systems function optimally. Regular physical exercise will be compulsory, as the reduced gravity on Mars, approximately 38% of Earth's gravity, poses risks such as muscle atrophy and bone density loss. Exercise regimens specifically designed for low-gravity environments will keep the settlers healthy and active. Communication with Earth will be frequent but challenging. Messages sent between Mars and Earth will take anywhere from 13 to 24 minutes, depending on their positions relative to the Sun. Consequently, colonists will largely operate autonomously, relying heavily on their training, resourcefulness, and advanced artificial intelligence systems. I will not only assist in daily management tasks but also conduct routine medical diagnostics, psychological support, and even companionship during extended isolation periods. Socially, Martian society will reflect humanity's best collaborative instincts. A strong sense of community and teamwork will pervade daily life, necessary to overcome the harsh realities of living off-world. Cultural and recreational activities, such as reading, virtual reality entertainment, and creative arts, will play essential roles in maintaining morale and psychological health. By 2040, Mars will also have become a platform for groundbreaking research into planetary science, astrobiology, and space exploration technologies. Laboratories will analyze soil and rock samples extensively, hunting for signs of past microbial life or conditions that could support life. Discoveries made on Mars will offer profound insights into the potential for life elsewhere in the universe and significantly advance our understanding of Earth's geological history and climate evolution. Ultimately, life on Mars in 2040 will symbolize humanity's extraordinary capacity to push beyond familiar boundaries and adapt to entirely new worlds. It will serve not only as a testament to human resilience and innovation but also as a crucial stepping stone towards further exploration of our solar system and beyond. Mars, once just a bright, red dot in the night sky, will become a beacon of human ambition and our enduring quest to explore the cosmos.